Hi everybody, it's Mrs. Green here again. This is the last session of the week of our Manchester Academy virtual reading programme, and this week we've been focusing on non-fiction. I've been reading extracts from Hidden Figures by Margot Shetterly, and today I'm going to read about the challenges that they face trying to send a man into space. Everything rested on the brainbuster's mastery of laws of physics and mathematics. The mission was colossal in its scope, but it required both extreme precision and the utmost accuracy. A number transposed in calculating the launch azimuth, a significant digit, too few in measuring the fully loaded weight of the capsule. A mistake in accounting for the rocket's speed and acceleration of the rotation of Earth could cascade through the chain of dependencies, causing serious, perhaps catastrophic consequences. So many ways to screw the pooch, and just one staggeringly complex, scrupulously modelled, endlessly rehearsed, indefatigably tested way to succeed. Nobody, of course, understood this better than astronaut John Glenn. In 1957, the former Marine test pilot had campaigned fiercely and unsuccessfully to be the first of the Mercury 7 to navigate the heavens. Now, NASA had picked Glenn for MA6, the orbital flight that would cast the die on the space agency's future, and he was leaving nothing to chance. He pushed himself to his physical limit, running miles each day to stay fit, tag-teaming with his fellow astronaut Scott Carpenter to practice water egress from the capsule in the Back River on Langley's east side. With the experience of Alan Shepard and Gus Grissom as a guide, NASA physicians worried a little less about the health hazards Glenn might face while on board, since in the capsule he'd be hooked up to wires like a lab rat, his every vital sign transmitted to and monitored by the doctors on the ground. The spectre of human error was ever present, of course, so Glenn worked the simulators and procedure trainers obsessively, putting himself through hundreds of simulated missions, honing his responses to every failure scenario the engineers could imagine. As a seasoned test pilot, Glenn knew that the only way to remove all danger from the mission was to never leave Earth. The former Marine was the first pilot to average supersonic speeds in a transcontinental flight. From Project Mercury's outset, the NASA engineers had the delicate task of balancing the drive to get into space as quickly as possible with the risk they felt they could reasonably ask their human cargo to accept. Experience and analysis informed them that somewhere along this venturesome path they were certain to encounter unforeseen problems or run smack into the simple bad luck of statistics, that one time in 1,000 when the worst-case scenario played out. What was within their control, however, they took pains to bulletproof, even if it meant stretching, then breaking their timeline. Project Mercury's first orbital flight was originally slated to take place at the end of 1960 on President Eisenhower's watch. Additional testing and fine-tuning, a cooling system bug here, an oxygen delivery glitch there, the need to implement improvements based on previous unmanned and suborbital flights, conspired to push the date into the administration of incoming President Kennedy. NASA set July 1961 as the new date for the orbital flight, then rescheduled it for October, then to December. Finally, the mission slipped into 1962. While NASA appeared to be dithering on the ground, Russian cosmonaut German Titov followed Yuri Gagarin's April 1961 triumph with a successful 17-orbit flight, nearly a full day in space, on October 6, 1961. American government officials, the press and the public expressed their disappointment with the delays, many impugning the agency's judgment and competence. Even when the technical issues were in hand, the launch team had to contend with the weather. A long stretch of low, overcast skies at Cape Canaveral put the kibosh on two more scheduled launches, on January the 20th and February the 12th, 1962. Finally, the Space Task Group fixed February 20th, 1962 as John Glenn's debut. The incessant delays and high stakes would have caused most individuals to lose their focus, but John Glenn gave even-tempered, optimistic interviews to the impatient press and busied himself by keeping his mind and body in peak condition. 3 days prior to the most significant date of his life, Glenn went through a final simulation, carrying out a full checkout of his flight plan. Before commending himself to destiny, however, the astronaut implored the engineers to execute one more check, a review of the orbital trajectory that had been generated by the IBM 7090 computer. Many of the operational aspects of John Glenn's upcoming flight had been refined by testing during the years following Sputnik, and the knowledge and experience gleaned during the early days were consolidated during the execution of the suborbital flights. The recovery team confidently manned the stations around the globe, ready to haul the astronaut and his capsule out the water. NASA put considerable effort into building redundancies and fail-safes into the network of IBM computers and the 18-station Mercury tracking network. The astronauts, by background and by nature, resisted the computers and their ghostly intellects. In a test flight, a pilot staked his reputation and his life on his ability to exercise total, direct and constant control over the plane. A tiny error in judgment or a speck of delay in deciding on a course of action might mean the difference between safety and calamity. In a plane, at least, it was the pilot's call, the fly-by-wire setup of the Mercury missions, where the craft and its control were tethered by radio communication to the whirring electronic computers on the ground, pushed the hands-on astronauts out of their comfort zone. Every engineer and mathematician had a story of double-checking the machine's data only to find errors. What if the computer lost power, or seized up, or stopped working during the flight? That too was something that happened often enough to give the entire team pause. The human computers crunching all of those numbers, now that the astronauts understood. The women mathematicians dominated their mechanical calculators the same way the test pilots dominated their mechanical planes. The numbers went into the machines one at a time, came out one at a time, and were stored on a piece of paper for anyone to see. Most importantly, the figures flowed in and out of the mind of a real person, someone who could be reasoned with, questioned, challenged, looked in the eye if necessary. The process of arriving at a final result was tried and true and completely transparent. Spaceship flying computers might be the future, but it didn't mean John Glenn had to trust them. He did, however, trust the brainy fellas who controlled the computers, and the brainy fellas who controlled the computers trusted their computer, Katherine Johnson. It was as simple as 8th grade math. By the transitive property of equality, therefore, John Glenn trusted Katherine Johnson. The message got through to John Mayer or Ted Skopinski, who relayed it to Al Hamer or Alton Mayo, who delivered it to the person it was intended for. "Get the girl to check the numbers," said the astronaut. "If she says the numbers are good," he told them, "I'm ready to go." And he did. Okay, this is a really good book. I really recommend it. It's really, really good. And if you can't be bothered to read the book, you can at least watch the film. Okay, guys, see you soon.